Welcome to part 2 of topic 2, production and costs, and what we'll be looking at in this topic is first of all production curves and second of all cost curves. Now ultimately it is the cost curves we'll be most interested in, but as you'll see, to understand the shape of the generic cost curves that we use in this course, you need to understand the production curves. So really the production curves are interesting in themselves, but they really do justify the shape of the cost curves, which is the most important part of this topic. So what we're dealing with here, as you can see in the top left hand corner, is the short run. So we'll leave the long run for now. We're just dealing with the relationship between inputs and output in the short run. In the top diagram on the horizontal axis I've got labour input, or the number of workers, and on the vertical I've got output, or the level of production. TP is the total product curve, so that just simply shows us the relationship between labour and production for a given level of capital. So just imagine in the top diagram we've got a factory, we've got 10 pieces of capital equipment in that factory, and the only way we can change output is by adding or taking away labour. So if we start off at the origin here and move up this curve, we are adding more workers. We've still got the same 10 units of capital, but we're adding more and more workers, and output is increasing, which is makes perfect sense. But the relationship between labour, input, and production is not linear. It's actually non-linear, and the shape of that non-linearity changes. So between the origin here and point A, as we add more and more workers, output increases at an increasing rate. Between A and B, as we add more and more workers, output increases at a decreasing rate, and beyond B, capital is getting so crowded that we're adding more workers, and the output level is actually falling here. Okay, so what's going on? Let's justify the shape of this total product curve, particularly between points the origin and point A, and between point A and point B. Beyond point B, no company would really ever go there, so we can safely ignore any points beyond point B. But let's start off here. What is happening from the origin? Well, we're actually experiencing increasing returns to labour. So what's happening is we're adding one worker to the production process. The worker enters the factory, there's 10 machines, and that worker is all by themselves. With that one worker, we can produce, say, 10 units of output. Now we decide we want to produce a little bit more. So we add a second worker to the production process and move a little bit further up this TP curve to 2 workers. Now production has increased to 22. So with one worker we can produce 10 units. With 2 workers we can produce 22 units. So the second worker has actually contributed an extra 12 units of output, whereas the first worker could only contribute 10. Now, is that because the second worker is better, smarter, more skilled than the first worker? Well, presumably not, otherwise we would have employed the second worker first. And this sort of an effect keeps going. With 3 workers, total production increases to 36. So it went from 10 to 22 to 36. So the third worker contributed an additional 14 units. And by being in a situation where each worker is contributing more marginal production than the previous one, that is what gives us this upward sloping curve, which is increasing at an increasing rate. Between A and B, what we're actually then doing is we are adding more and more workers, but each worker is contributing less and less marginal production than the previous one. So between A and B, we're actually experiencing diminishing returns to labour. So between the origin and A, increasing returns to labour. Between A and B, decreasing returns to labour. Now, we can then think about this in terms of the marginal product of labour. To the left of point A, as we add more and more workers along the horizontal axis, we're in the diagram down the bottom now, as we add more and more workers, marginal output is actually rising. And that's what's making the total product curve have this convex shape, or increasing at an increasing rate. Past A down to point B, marginal product, that is the extra output, is declining. So in terms of the numbers on these curves, on this curve, this MP curve, the first worker would be at 10, the second would be at 12, the third would be at 14, using the numbers that we used previously. So really, the TP curve motivates the shape of the marginal product curve. When beyond B, total product becomes negative, so therefore marginal product total product begins to fall beyond B, so marginal product begins to become negative. Okay, so just keeping in mind that the marginal product curve just shows the first differences in total product. So let's move on. We've got this shape of the marginal product curve. We can use that to then motivate the shape of the marginal cost curve. Now we know we've already gone through the marginal products curve. We've got labour on the horizontal, we've got production on the vertical, and capital is fixed in this top diagram. But this MP curve really shows us how the productivity of each worker changes. As we add more and more workers, productivity rises, then begins to fall. Now, one thing that I haven't done is explained why marginal product rises and then begins to fall. So I'll do that now. Marginal product, the marginal product of our first worker, we said that was 10. The marginal product of the second worker, then we said was 12. The marginal product of the third worker was 14. So why is it each worker is contributing more than the previous one? Well, the main reason, there are various reasons given in different textbooks, but the main reason and the most intuitive one is that as you add more and more workers along this horizontal axis in the top diagram, as you add more and more workers, these workers can begin to specialize. So with one worker, that worker needs to do everything from the accounting to the marketing to the manufacturing to repairs. That person needs to do everything. With the introduction of the second worker, they can begin specializing in terms of the tasks they do within the factory, and that boosts their productivity, their individual productivity. The third worker allows even more specialization. So really, when we talk about marginal product going from 10 to 12 to 14, as we add workers numbers 1, 2, and 3, we're actually showing the benefits of specialization here. So for the third worker, we said that the marginal product of the third worker was 14 units. It's not as if that third worker is responsible solely for all of those 14 units. The additional 14 units is really a result of the 3 workers working together now better as a team and specializing. Once you go beyond point A in the top diagram, then all of the gains from specialization, or all of the potential of specialization, has been exhausted, and because of the fixed amount of capital, adding more and more workers allows you to increase production, but the productivity starts to fall of each additional worker. Okay, so that motivates the shape then of the marginal cost curve. To the left of the dotted line that's running down from point A, to the left of that, each worker is allowing team productivity to grow. Now, if team productivity, because of specialization, is growing, it must mean that that team is driving down the marginal cost of each unit of output. So we've got this inverse relationship between the marginal productivity of each worker and the marginal cost of production. So as this team works better and better together, the marginal product rises, and that allows them to produce each additional unit at a cheaper cost per unit. So marginal product, marginal cost. Next thing we've got to look at is the complete set of curves, and these are the curves that we'll be using in the next topic and the topic after that. So this generic set of curves is very important. Now, what I'm going to do here is just point out a couple of key features of the shapes of these curves and the relationship between them. And really, it's going to be up to you to go to the textbook and other sources of information to really understand or take what I'm about to say and extend your understanding. Okay, so we've already worked out that the marginal cost curve has its shape because of the MP curve, and the MP curve has its shape because of the TP curve. So really, the TP curve is just a technical relationship between L and Q. Once we got that, we got the shape of the MP curve. Once we've got that, we've got the shape of the marginal cost curve. So really, the marginal cost curve is almost determined by the technical relationship between labour and output for a fixed level of capital. Marginal costs are just variable costs. Okay, so as we produce more and more output, marginal costs change. The only costs that can possibly change are variable costs. So what we're seeing here with the marginal cost curve is how variable costs change as you change production. Now, if we consider marginal cost of the first unit, that's actually, the marginal cost curve is going to come up and it's actually going to be at the same point as average variable cost. Now, some of you may need to think about that, but I've got it over here in the technical notes on the right. The marginal cost of the first unit of production might be, say, $50. That is also going to be equal to your total variable costs. And because we're only producing one unit of output, your total variable costs also equal your average variable costs. So if you produce the first unit of output here, right close to the vertical axis for $50, your average variable cost is going to be $50 as well. Marginal costs then fall quite rapidly, and they're very low over this range. When marginal costs are low, they actually drag average variable costs down with them. Now, this is explained quite well in the book, but I'll go through a simple example for you. Let's just imagine you've got 4 tests in this unit, and for the first 4 tests, your scores are 10 out of 10, 10 out of 10, 10 out of 10, and 10 out of 10. Your average score is therefore 10 out of 10. For the 5th test, you score 5 out of 10 for whatever reason. Now your total marks are now 45 and your average falls to 9. So what does that tell us? Well, it tells us if we have a marginal value which is less than the existing average, then that marginal value, that low marginal value, drags the average down. And that's exactly what's happening here in the bottom left-hand corner of this diagram between the marginal cost curve and the average variable cost curve. The marginal cost curve is low and falling, and it's dragging the average down. The marginal cost curve then begins to rise. But the marginal cost curve here, where it first starts to rise, is still below the existing average. So the average variable cost curve still declines. They intersect at that point. MC, ABC intersect at that point, and then the marginal cost curve begins to start rising quite quickly. As the marginal cost begins to rise and as it rises above the average variable cost, these marginal values of production, these marginal values of the marginal cost of production, begin to drag average variable cost back up. And so that's really the motivation behind the shape of the AVC curve. In terms of average total cost, what is the vertical distance between ATC and AVC equal to? It's actually equal to average fixed costs. And the way I've drawn these diagrams is that average fixed cost starts off quite large and then these curves get closer and closer and closer together, indicating that average variable cost is declining. Average fixed cost is declining. So as we move from the left to the right, because these two green cost curves are moving closer together, that indicates average fixed cost is declining. And it's declining because as you produce more and more units of output along the horizontal axis and move from left to right, your fixed costs are spread out over more units of production, and therefore your average fixed cost is actually declining. So the MPC curve gives us the shape of the AVC curve, and the fact that as you produce more, your fixed costs are spread out over more units of output, that then gives us the position of the ATC curve relative to AVC. Okay, so they are the important curves that we need to consider in this course. Okay, the next thing. The marginal cost curve, as we will see this week and next week, really helps us determine the optimal level of supply. In fact, it's a supply curve. The marginal cost curve is a supply curve. Let's think about it this way. Let's just imagine that this is your marginal cost curve. You're that manufacturer we were talking about earlier, and this is your marginal cost curve. If the price is P1, how much are you going to produce to actually maximize your profits? Well, the amount you should be producing to maximize your profits is at the intersection point between the price P1 and the MC curve. So if we take a line down there, that is the profit maximizing level of output. If, however, you only produced Q2, the problem is you've got units of output which have production costs or marginal costs much lower than the selling price of the output. So this little triangle in here, which I've labelled unexploited profit, is exactly that. It's units of output for which the marginal production costs lie below the selling price of that output. So to maximise profits, this producer should produce where price equals marginal cost. Now, the interesting thing here, and the very important thing, is in determining how much a firm should produce to maximize profits, fixed costs are not relevant. I have worked out how much this firm should produce using simply the selling price of this product in the marketplace and marginal costs. And marginal costs are just variable costs. So that marginal costs are costs that can change or do change with the output level. So all marginal costs must be variable costs. So nowhere in this diagram have I referred to or drawn in any fixed costs. The one thing to keep in mind as we're doing all of this that I haven't really touched on, but I'll get to later, is that opportunity costs are built into these cost curves that we've been talking about. But we'll come back to that a little bit later and I'll explain to you why it's important. Okay, now we add in the AVC and the ATC curve. So we're still in the short run. A firm that wants to maximize profits, given a selling price in the marketplace of whatever good they are producing of P1, will produce the output level Q1. If this firm goes beyond Q1, it will be producing extra units for which the marginal cost curve is higher than the selling price. So going beyond Q1, you're actually throwing money away at the margin by producing those extra units. And this is the position where I've got the ATC curve. That's quite typical, quite a typical starting point for analysis in microeconomics. So I've got the price line parallel to, or tangential to, the minimum point of the ATC curve. So what we've got here is a situation where a firm is earning P1 per unit, they're producing Q1 units, so their total revenue is P1 times Q1. But at the same time, their total costs are the same area, P1 times Q1. So this firm is in a situation where its revenues and its total production costs, or its total costs rather, are the same area, P1 times Q1. So all of this area in here is a measure of total revenue and total costs. Now, it would be very easy, and some people do make this mistake, it'd be very easy to look at that and think the company is making no money. Well, that's not wrong. That's not right. That's wrong. This company is making money because when we refer to this area P1, Q1 as total costs, those total costs represent fixed costs, variable costs, and implicit or opportunity costs as well. So this company is making enough money, enough revenue to cover their fixed costs, their variable costs, and their opportunity costs as well. So in the sense of accounting profit, this company is making a positive amount of money. And the accounting profit this company is making when producing at this point here, the accounting profit is exactly equal to the company's opportunity costs. So it's making just enough profit to stop it being tempted to move into another industry. So in terms of this diagram, P1Q1 is very often called the break-even point, but it's so important for you to remember when you see that point, when a company is just breaking even and covering all of its costs, it is still making accounting profit. It's just that its economic profit is zero. So that's an important distinction. Okay, next what I've got is some estimated cost curves for a corn farm in the United States, and this came out of an academic publication, or series of publications quite a few years ago. Someone actually went out and measured the marginal cost curve of corn farming in the United States. And what you can see is that, sure enough, the marginal cost curve does actually rise as expected, and the AVC and ATC curves have very similar shapes to the generic set of cost curves that I showed you previously. So think about this situation. Along the horizontal axis, we've got thousands of bushels of corn, and this farmer presumably has a fixed amount of land. The farmer has a fixed amount of capital. But the farmer can actually produce more by adding more water, more fertilizer, and more labor. But what you can see is because of the constraints of the fixed amount of capital and presumably land as well, we'll assume land is fixed because this is a short-run analysis. Because of those constraints on capital and labor, as the farmer tries to produce more and more and more, the marginal production costs do begin to rise. And interestingly, it's not a smooth rise. What actually happens is marginal production costs start off to be very, very low, but then they start increasing at a very rapid rate. So this really shows the constraint that the farmer faces. So given a expected price of 70 cents per bushel, if you take a line horizontally from 0.7 on the vertical axis across to the marginal cost curve, that would be the profit maximizing level of output this farmer can actually produce. So because of the shape of the marginal cost curve, these marginal costs, these rapidly rising marginal costs, represent a very large constraint on the farmer's ability to actually increase production. Okay, next example is looking at electricity generation, and once again we've got a real world marginal cost curve here. So previously I showed you a marginal cost curve that was upward sloping, had a nice smooth slope, but in the electricity industry the marginal cost of electricity generation is more of a step function. So we've got very cheap hydro on the horizontal, very cheap nuclear, then coal-fired, oil-fired, diesel-fired. Now the thing to note here is that hydro is very cheap in terms of operating costs or variable costs. Now, of these different ways of generating electricity, hydro is the most expensive. In terms of capital costs, in terms of fixed costs, hydro is the most expensive. But in actually generating this marginal cost curve, the person who generated this marginal cost curve hasn't considered the high fixed cost of hydro. They're only focusing on the low variable costs of hydro. Same with nuclear, very high fixed costs, but that's not relevant in determining the marginal cost curve, which is a supply curve. We only focus on the variable costs. Then you go coal-fired is the next cheapest in terms of variable production costs, then oil-fired, then diesel-fired. And so that's an example of another example of a real-world marginal cost curve or a real-world supply curve. And by looking at this particular supply curve, you really can see that it does help the market determine the market price and how much is going to be produced. So for example, the demand curve furthest to the left is D off peak. Now, for that much production, we look at the intersection of the demand curve and the supply curve, and we have this cost of $25 per megawatt hour for coal-fired electricity generation. The amount produced, well, the system would be at roughly 68% capacity, 67% capacity on the vertical axis. But then when we go to peak, the demand curve is much further to the right, and what we can see from this marginal cost curve is that for this much production, for the system to be at, and I'm looking at the intersection of the D peak curve and the diesel-fired part of the supply curve, the system would have to be at roughly 88% capacity, and the market price is going to have to be 65. So this gives you this real sense of what happens when demand changes. As demand increases from off-peak to intermediate to peak, we've got to go to more and more expensive generation technologies. And because we've got to actually start firing up oil-fired and then diesel-fired capacity, the market price needs to rise to reflect those high production costs. So, as I said, this is a marginal cost curve, and marginal cost curves are also supply curves. And given demand, this type of marginal cost curve, this type of real-world marginal cost curve, helps regulators work out what the price needs to be to charge consumers a fair price at different times during the day, and also to reward the producers with a fair price to cover their production costs. And then finally, this is something which will be quite important in next week's topic. What I've got here is quite an old article, 2006, but I do like it because it really does show you the impact of market price on costs. And what it's got here is that back in 2006, 12% of the Murray Valley grapes were left to rot. So they were in a situation where the market price of wine was so low that it actually fell below the variable operating costs of the wineries. So these companies were in a situation where the market price of wine was actually less per unit than the variable production costs of producing that wine. And so that's a situation where the price can get so low that manufacturers can't even cover their variable production costs, in which case they will shut down operations and produce nothing. In this case, it probably would have been just a percentage of the crop that was not produced, not processed, but it's going to be a familiar concept when we hit next week's topic.